So hello again. Tonight we're going to talk about lunar impactors. This is, if you've heard about that asteroid that was going to hit the Earth, that isn't going to hit the Earth according to current observations, but might hit the moon. So we'll talk about what happens when things might hit the moon. The asteroid known as 2024 YR4 goes around the solar system every 4 years. It was 2020, 2024. They recognized it. 2028 and 2032. It's what is known as a near Earth object. And they'll get a better handle on what its actual orbital path is in 2028 when it makes its next flyby. And it'll fly between the Earth and the moon. And that will give them an understanding of what will actually happen on the subsequent flyby, which is 2032. Initially, it was believed to be Earth impacting by about 3% probability. And now they've continued to do observations on it and have indicated that it's 0.004% that it's going to hit the Earth. So lucky Earth, very low probability of hitting the Earth, but it can interact with something and that could change. But what it did do is basically say it's moved from going to hit the Earth to moving up a little bit in its orbital path and maybe going to hit the moon. And the lunar impact probability is around 1% at this point. But we won't know reliably where it'll hit the moon, if it'll hit the moon, and those kinds of things until the 2028 pass. But they have to go back and look and say, we kind of discovered it in 2024. What were the details in 2020 or 2016? Because it comes by every 4 years. So the size of something impacting something else and what it's made of and what it hits and what that's made of makes all the difference in the world. The first thing that people will usually ask is, if it's going to hit something, how big is it? This particular asteroid, 2024 YR4, is currently estimated at 90 meters or about 300 feet in diameter, but it's not circular. It's kind of a little bit elongated. So that's at its longest dimension. If it did hit the Earth, which current probability says it won't, but if it did hit the Earth, it would not be a planetary extinction level event, an ELE. It would be what they call a city killer. It would be a large enough impact that if it hit like New York City, no more New York City and surrounding areas. You know, if it hit a small state, it could essentially eliminate most of the population of that state. If it hit a small county as opposed to like a large county like LA County in California, then it could take out a small county. But even if it hit somewhere, there are side effects. If it hit something that was relatively soft, it would create an ejecta, debris cloud. Or if it hit water, it can create a tsunami or a tidal wave going inland if it hits just offshore on the continental shelf. If it hits any large farming area, it could take out farm crops for, 10 years or something. If it hits a large pasture area, it could take out a lot of farm animals. So if it hits, let's say, a freshwater supply of a source of fresh water for an area, it could take out potable water and you'd have to pipe it in. And then even if it did hit a less populated area, there's the effects to the area and the human migration and immigration into other areas that would be a consequence. So even though it didn't destroy the planet, didn't take out a large area of a country or a continent, it would have significantly disruptive effects. But how it makes it better or worse is where it winds up, what it impacts, how fast it's coming in, whether it's spinning or not, the angle that it impacts, whether it's shallow or steep, the materials that it's made out of. Is it a rubble pile loosely held together with the gravity and static electricity? Is it mostly stony stuff, or is it metallic, or is it a mixture? Is it like a comet? A comet that's been around for a while would be porous because a lot of the ice has been bled off. And so if it hits the atmosphere hard, it could just blow it apart and shatter it. Or is it solid? It's not a comet, it's an asteroid, and it's like stony metallic. That would be worse. and then where it hits. Is it a body of water, sand, stone? Did it hit a mountain that's mostly metallic? Did it hit a volcanic area? Is it going to open any new volcanic vents or start a super volcano? And then how fast it's coming in, the velocity. Velocity has two components, that's speed and direction. So sometimes people speak of the velocity when it's coming in. Other times it's just speed. Well, the common vernacular we think of as speed, how fast it's coming in. But you really want, when you're calculating the orbits, to calculate the acceleration. The acceleration is velocity over time and can be increasing or decreasing. So the more scientific observations will speak of acceleration, and you'll think that means it's going faster. No, acceleration can be positive or negative. Negative deceleration is sometimes referred to as deceleration or slowing down. When the asteroid is traveling through open space, it's at about 40,000 miles an hour on average. But as it orbits something, let's say it's orbiting the sun and it's an elongated orbit, the speed varies with where it is in the orbit. If it's at the ends, the narrower end or the wider end, that's the aphelion and the perihelion in the case of orbiting the sun. And it can slow down as it gets far enough away from the sun and speed up as it zips around the sun. And in the middle, it's kind of an average between the two. But let's say it was Earth impacting, coming in directly to the Earth, then most of the times they'll comment these on kilometers per second or kilometers or miles per second. And that doesn't give people a real good feeling of how fast is that? Well, for folks on the metric system, 17.32 kilometers per second doesn't sound like it's going all that fast. 17 is a small number. But then you multiply it for an hour and you're like, that's 62,000 kilometers per hour. Well, 10.76 miles per second. 10's a relatively small number. How fast is that? Well, that's 38,736 miles per hour. Well, that sounds like it's a lot faster. Well, that's kind of like incoming speed. The Earth has a dense atmosphere. So if it were coming into the Earth, the atmosphere would slow it down somewhat and might actually break it apart, like the Chelyabinsk meteor that came in over Russia about 10 years ago. Luckily for this asteroid, we're not expecting it to impact the Earth, but there's a probability right now of it impacting the moon. It's a non-zero probability. Small, but let's think about what that would do. So if it's going to hit the moon, it's lunar impacting. How fast is it going to be coming in? Well, when it's in space, it's going to be going that same roughly 40,000 miles an hour. The moon has lower gravity. So you would think that it won't accelerate that much coming in. But then again, the moon doesn't have much atmosphere. So even though the gravity is lower, its ability to accelerate it would increase. And the reduced atmosphere of the moon would say there's less chance of it breaking up prior to impact from the shock value of hitting the dense atmosphere. But still, it'll be a little less. So 50,000 kilometers per hour or 31,000 miles per hour. Not that much different than if it came in to hit the Earth. So we have a rough path of where it might hit. And it's this green line you see on the right going from the upper right, the northeast of the moon, down towards the south center of the moon, or from mare Crisium, which is a mare, a solidified rocky lava plain, all the way down to Tycho, which is a big splash crater down towards the bottom center of the moon. We don't know exactly. We kind of know if it's going to hit the moon, it'll kind of be along this path, but it's low probability. And until we get to like 2028, we won't have any really good understanding of, where it's going to wind up. So I can't even tell you something like, well, I know it's going to be hitting on the near side of the moon, but I can't tell you what the phase of the moon will be at the time, because I don't have an impact date down to a day. I have an impact date down to several months. I can't tell what time of day. So let's say the Earth is facing the moon at that time, it happens to be like a half moon, I can't tell if your side of the Earth will be facing that side of the moon at the time. Earth rotates, moon goes around the Earth. And I can't tell the angle that it's going to impact the moon at. But I do know that given the size of this object and the approximate speed that it's coming in, a presumed straight in impact, it'll make a crater about 2 kilometers across or 1.2 miles, which if you're looking from the Earth to the moon and the moon's a half a degree in the sky, it's just a pinpoint poof. It's not going to like make a giant mushroom cloud on the moon. If you were on the moon, it would be serious. But from the Earth looking at the moon, even if you had a good view, it's not going to make that big a impact on the moon. So what about the angle? Well, if it comes in at an obtuse angle, pretty much, 90-degree straight in, it'll make your typical somewhat circular crater. It'll have an upwelling point in the center. And this is essentially going to produce something called ejecta. So it's kind of like if you drop a stone into a sink full of water and you see the stone go in, it kind of like moves the water out of the way when it hits, and then the stone descends. And as the water comes back, it makes this upwelling of material, and that's the ejecta. If it comes straight in, most of the force will be directed downward. And if it hits an area that is likely to become molten, like take the heat and make it into molten rock, then that will stop a lot of the ejecta from blasting upwards, and nothing will go into lunar orbit. And it might not even splash up enough to leave lunar orbit and head towards the Earth. But knowing that the near side of the moon is where this is going to impact it, if it impacts it in an area that's harder rock that doesn't liquefy, then there's a higher probability of some of that ejecta making it to escape velocity of the moon. The moon being smaller, the escape velocity is lower, which means it could come back towards the Earth. Well, we won't know until 2032. So in 2028, we'll know it's going to hit about what time, where, but until it actually creates the ejecta, we won't know how much of that ejecta is going to make its way back to the Earth. And it's going to be varying speed. So some ejecta might arrive in a few days. Other ejecta, if it's sort of shotgun blast scattered, it could take weeks for it to all come back in. But until 2032, we won't know what. The physics and the math says whatever the impact was on the moon, if there's ejecta that comes out and heads back for the Earth, that total ejecta is going to be less than the ejecta that was produced on the moon, because it's going to be scattered. The Earth's gravity would accelerate whatever's coming in. So we won't know until 2032 if it hits the moon, what the effect will be on the Earth. Let's say it comes in at an oblique angle. This is not that high probability of occurrence. If it's coming in at a very shallow angle, it won't skip across the moon like a rock on a lake, because there's not any atmospheric aerodynamic effect to lift it up again. It'll just make a scoop into the ground and it'll be elongated. It'll make a gouge in the surface. If it does, then the material that it brings up won't go straight up. It will be accelerated, and it's likely to go into a low lunar orbit. Since the moon has lower gravity, it may produce kind of a temporary lunar halo, a lunar ring. Like Saturn has rings, the moon for a time could have a ring. And that debris is less likely to make it to the Earth because it will be in lunar orbit. As I was mentioning, it's probably not going to do the stone skipping on water effect, because we don't know the actual shape of this asteroid. So we don't know if it's flat. We know it's somewhat elongated, but how it impacts, if it impacts shallow with its flat side down, then it's more likely to hop a couple of times. But we won't know until 2032. So I've got a question for them. All the observers looking at these things, they gave me this. Well, it could impact anywhere from Mars Crisium all the way down to Tycho. Okay. That would be from the northeast to the south central. but then you see the orbital path on the right diagram there, and it's going to be going from upper left towards lower center. That's not the same angle. So which picture is right? One of these two pictures is flipped. Maybe in 2028, they'll do a better job of scientific representation of the orbital path and the potential impact path on the moon. But remember, in space, there's no up and down.
Right.
I get that all the time. Like, am I looking at the moon right side up? Well, you're standing vertical, so I guess you are. No, is the moon, when I look in the telescope, is the moon right side up? It's right side up. Well, then you have to explain optics to them and eyepieces, and do you have mirrors? Do you have lenses? Is it a doublet lens or a triplet or quadruple? It's what you see. So, it's good to know that this asteroid has a low probability of impacting the Earth, but we're going to keep watching it, and things may change over time. It's unfortunate for the Earth if it does impact the moon and results in ejecta that makes it back to Earth. But we won't know until it actually happens whether or not it's going to hit the moon, and if it does, where and what angle and what its shape is and all those kinds of things. End result could be it passes between the Earth and the moon and nothing at all. Maybe we'll get to see it as it goes by. Or if it does produce ejecta because it's a straight in hit, it could be an interesting light show. So, might be able to see a little bright spot on the moon for a fraction of a second when it actually impacts. Assuming that, wherever your observatory is pointing at the moon at the time, and that the area that it impacts is kind of just on the other side of the terminator, the shadow of the moon. So you have to get the right phase of the moon. What you want is where it's dark where it impacts and light on its approach. So you can see it approaching and then it disappears into darkness. And then you see a little boop as the ejecta rises up above the terminator. So it could be an interesting impact, a lunar ring, interesting meteor shower for a few years. We could have some Chelyabinsk size impactors on the Earth. The Chelyabinsk was 18 meters or about 60 feet. That one blew up in the Earth's atmosphere about 70 miles up. It could be interesting.
And this thing is how big?
See, I put that in the very first slide.
I know. I forgot. Comparing it to this one.
90, 300 feet.
Yeah, that's what 300 feet. Yeah. If a 300-foot rock hits the moon, does it make a sound?
Yes. Seismographically, the moon will ring like a bell. Now, how do I know that? Because during the Apollo missions, there was a third stage. This was not the capsule or the service module. This was the third stage that pushed it to the moon. That third stage, they would occasionally say, hey, why don't we throw something at the moon? So they would take the third stage and deliberately have it hit the moon after Apollo 11. So Apollo 11 dropped off some seismographs. So it's not earthquakes, it's moonquakes. So they could measure the moonquakes caused by the third stage smacking into the moon. They found out the moon rang like a bell. The moon ringing like a bell tells you a couple of things. The moon is stony. The moon is not metallic, and the moon has layers and different densities. So when the impact occurred in one part of the moon, it distributed the sound compression over the moon, and it went around the moon. So it rang like a bell. Yeah, it wasn't just one shot. It was a high amplitude ring followed by lower and lower and lower amplitude rings. If this thing hits the moon, I don't know if the seismographs from Apollo are still operational on the moon. They were powered by solar panels, which those degrade in 50 years. Don't know if they're still working or not. Don't know if we have any seismographs on the moon at the moment, but that would be an interesting thing to think about. Is are these recent landers that are on the moon, are they equipped with any seismographic instruments? Because this could be something they could look into. Whether it's going to impact where, how bad it's going to be, check back in 2028. And then some links. So if you didn't know about Chelyabinsk, there's a link to the Chelyabinsk meteor impact over Russia. And then the thing that can change orbit is the sun's solar wind radiation on the asteroid can actually adjust its trajectory. So even by not hitting it with anything, it can still move. I don't want it to hit the moon because there are unknown side effects, and I'd rather we not have any of those. I'd rather it did just like it's done for lots of years now, gone between the Earth and the moon. The Earth has to be in its place in the orbit around the sun, and the moon has to be in its place in the orbit around the Earth, and then this thing has to be coming in to cross that orbital plane. So you've got, oh, look, there's a three-body problem. Those are hard to calculate. So as we keep observing this asteroid, we get better and better information about its orbital path. We already have good data about the moon and the Earth, moon around the Earth and Earth around the sun, but we need to know the asteroid's orbital information a little better. And as for getting a better picture of it, there was this place in Puerto Rico called Arecibo that we used to use for radar imaging of near-Earth asteroids and comets. We don't have that anymore. What we do nowadays is we use the commercial private radio astronomy antennas out in California that are part of the Allen array. They transmit the radio signals out to the asteroid, and then the reflection that comes back is picked up by the one of the dishes in California that are part of the NASA Deep Space Network. So the Deep Space Network is not only used for satellite communications, for deep space probe communication, it's also used for receiving the radar reflections off of near-Earth objects to judge how big they are, what their shape is. Are they smooth, rough, elongated, spherical? Are they rotating? How many axes are they rotating in? All that stuff comes back from the radar image. And I think at the moment, it's too far away to get a good radar image of it. They kind of saw it after it was already going by in 2024. And they're like, hey, maybe we ought to pay attention to that. But we won't have a good approach radar image of it until 2032. To be determined.
You would think that the whole world would mobilize to get some good views of this thing.
Yes.
You know, radar, optical, anything. If it's going to be close enough, it's worth observing.
Yes. And since it's flying at 40,000 miles per hour between the Earth and the moon, we can't launch a spacecraft to land on it. Because if we launched it from the Earth, the most we'd be going is about 26,000 miles an hour, and it would go by. So we would have to actually get into its orbital path and do a delta V acceleration faster than the asteroid to catch up with it. And we don't have the rocket capability to do that at the moment.
So we'll just look at it.
So we'll be good to look at it. So we could put instruments on the moon. We could land instruments on the moon.
Yeah.
Put some things down along the path, get some good shots of it. We could have a lunar orbiter that we adjust its orbit to be tilted to line up with the impact path. And so we could get a good view of it. There's all sorts of things we can do if the humanoids on this planet want to spend the governmental budget money to do something like this, to learn about things that could hit us or the moon. I think there will be some money spent, but I don't think there'll be a lot of money spent to do something unique for this.
Well, the amateurs would be on it.
I could be surprised though.
Yeah.
Remember, there are more people working at your average McDonald's than there are people on the planet that are exclusively assigned to looking out for things that could hit the planet.
Well, then all you got to do is get the people at McDonald's to look after the planet.
And that's my thoughts exactly. If you can make money off of it to the tune of $10 per person, then you could afford the staff of McDonald's and put those to work as technicians on observatories around the planet.
Yeah.
Okay. Any other comments or questions? Otherwise, I'll stop recording. Hearing nothing.